Okay, for our last topic, what we're going to discuss is the non-centroidal rotation or dynamic equilibrium. Okay, so for the last two topics, we've discussed on the relationship of rectilinear translation and rotation, and we have this kinetics of rotation. So this is for the last part of our rotation topic. In relation to the non-centroidal rotation dynamic equilibrium, these are the steps to apply to this topic. First, we have to apply the reverse normal effective force or weight over the gravity multiplied by r bar omega squared, also known or called as the centrifugal inertia force, acting radially outward through the center of gravity opposite to the direction of normal acceleration. And then, apply the reverse tangential effective force, W over G multiplied by radius times the alpha, also called as the tangential inertia force, acting through the center of gravity opposite to the direction of tangential acceleration. And then, apply the inertia couple I bar alpha anywhere on the body and acting opposite to the sense of alpha. Okay? So, to apply this, let's have our sample problems. Okay? In this, now first, a man weighing 161 pounds seated on a horizontal turntable 2 feet away from the vertical axis of rotation. The coefficient of friction between him and the turntable is 0.4. If the turntable starts from rest and accelerates at the rate of 1/2 rad per second squared, how many seconds will elapse before it starts to slide? Determine the angle theta of the direction in which he will slide. Okay? To answer that, first we have to compute for the omega or the angular velocity. Okay? To compute for that, we have to apply the first equation wherein that is the summation of force N or normal is equal to W over G times R omega. Okay? So, therefore, F is equal to W over G R omega. So, that is binanggit sa problem that the coefficient of friction is 0.4 times the normal force, yung weight na 161, okay, is equal to 161 over G na 32.2 feet per second squared times 2 na radius, yun daw yung distance nila, ito, ayan, okay, so times the omega, ito yung hinahanap sa atin, therefore our omega is 2.537715508 rad per second squared, yung angular acceleration natin. Yan. So, if we have this, ating angular acceleration, or should I say angular velocity pala, so ano lang siya, second lang, hindi siya squared. So, we could actually compute for the angular velocity, for the time, Now, the time, ano ba yung nasa atin? The time, yan, that will elapse before it starts to slide. So, gamit yung equation kayo sa rotation, omega is equal to omega initial plus alpha t. So, our omega initial, ito na-compute natin, yung 2.537715508 is equal to omega initial natin 0 plus 0.5 t. Nabanggit naman sa problem that our alpha is 1/2 rad, ito, yan, per second squared. So, therefore, our omega or initial, or yung ating, or should I say, yung ating time, that will elapse is equal to 5.08 seconds. So, ito yung isa sa mga hinahanap sa atin sa problem. Okay? Ayan. So, this is the time that will elapse, before it starts to slide. Okay? That is 5.08 seconds. And then, for us to find the theta, or the angle, we're going to use the formula that is A sub t is equal to R alpha. Okay? So, A sub t is equal to R, given sa atin na 2 times yung alpha 1/2 rad per second squared, or our acceleration tangential is 1 feet per second squared. Yan. And then for the normal, that is R omega squared. So, normal is ating radius is 2, multiply by omega squared yung kanina ay 2.25377 na naka-square. Therefore, our normal acceleration is 12.88 feet per second squared. Yan. So, to compute for the theta, that is equal to tangent theta is equal to a sub t over a sub n. So, same thing yung our curvilinear translation, no? Na nakaikot. So, therefore, that is tangent theta is equal to 1 over 12.88. So, therefore, theta is 4.44 degrees. And this is our answer for this problem. Okay? So, ito yung ating angle, no? To angle of the direction in which he will slide. So, in short, from this illustration, do sa left side, ito yon, no, yung pinapahanap sa atin. Yan. Okay? So, okay, let's have a quick recap on this problem. So, pinapahanap sa atin is the time that will elapse now before he start to slide and the angle. So, to find for the time, we have first to find the angular velocity dahil iikot nga siya. So, having this formula from the summation of forces, actually summation of forces along the normal or horizontal, na pero we derive it from the normal na lang kasi mukhang weight lang naman ng tao yung pinag-uusapan. So, that is F is equal to W over G times R multiplied by omega squared. Yung unang step, no? Ito yung pinagamit sa atin. Okay? And then we computed for the omega or the angular velocity. And then applying that to the equations of rotation. Ito po. Yan. Then we have this time na 5.08 seconds. Then next, pinagamit sa atin yung theta or angle, no? Na direction ng kanya pag-slide. So, ito ay with respect to the x-axis. So, kung dito galing, mukhang pababa, no? Pababa sa x-axis. So, that is, gamit yung ating tangent theta, ito is equal to a sub t over a sub n. Therefore, our theta is 4.44 seconds. Okay? That is for the time for the man, no? Do sa our time and that angle, no? Na kanya mag-slide. Okay? So, for our next problem, here, a uniform slender rod weighing 96 pounds is fastened to the rotating frame in the figure by a smooth pin at A and horizontal cord at B. The frame rotates about its vertical axis at a constant speed of 4 rad per second. Yan. Find the tension in the cord and the horizontal vertical components of the hinge reaction. So to solve this, no, we have to find first, no, yung ating mga components, no. So mga pinapahanap naman sa atin sa problem ay mga tension and horizontal and vertical components. So, mga forces ang pinapahanap sa atin dito sa problem. Okay? So, to solve that, first we have to apply, no, or ihiwalay lang natin yung ating tension or yung ating rod AB, no, yung ating rod AB. So, from that, no, dito na lang siguro, pag iniwalay natin yung ating rod AB, ito siya, no, yan, this is point A, and this is point B. So, sa point B, meron tayong tension, okay, coming from yung tayo ng figure. Then, sa weight, yan, meron tayong weight sa gitna, diba? Meron din tayong, yung W over G times R omega squared. Yan. Ano pa? We have this RAH, no? Horizontal, and RA vertical. Yung weight natin, this is 96.6 pounds. Ay, wala pa pala, no? Hindi pa natin nako-compute. Pero we have this given. Given ba yung weight sa atin? Ayan. Tama. 96.6 pounds. So, 96.6 pounds na weight. Yan. And then, masasolve na natin. Okay? So, let's start by summing the moment at A equal to 0. So, that is 60. No? Alam ba natin yung mga distances? So, given, no? Actually, given siya, no? Ito. Yan, we have this 6. Ito, 5, then 2. Okay? So, ilagay na lang natin. So, yung height natin, doon sa illustration natin ay 6. Ito pala ay 6, no? Dito na lang. Ay 6. Okay? Then, ano pa yung mga values ng moment? Yan lang naman ang kailangan natin. Wala nang iba, no? 6 lang. So, summing up the moment, so that is equal to 60 minus 168 times 3 times 96 times 1.5 is equal to 0. Now, saan galing yung 168? Galing siya dito sa ating, ayan. So, binigay sa atin, di ba, na lumalabas na ano, na, ito, no? Ayan po, no, yung ating illustration. So, 168 ay galing po dito sa ating WG, ito siya. That is weight over G times R omega squared. Okay? So, that is equal to, lagyan na natin dito, equal to 96.6 over 32.2 times yung radius na 3.5 times omega squared na 4 squared. So, this is 168 pounds. Ito po yun. So, continuing dun sa ating kinocompute, that's the summation of moment at A is equal to 0 na 60 minus 168 times 3, ulitin ko na lang, minus 96.6 times 1.5 is equal to 0. Therefore, our tension, no, diretsong answer na is 108.15 pounds. Ito yung isa sa mga answer natin na hinahanap. Okay? And then, let's move with the summation of forces vertical, no? Equal to 0. That is, lalabas na lang RAV, no? From this illustration, parang RAV is equal to the weight. So, equal lang siya sa 96.6 pounds. Okay? And this is our answer for that. And then, para sa horizontal, magsasam lang tayo ng forces horizontal na equal to 0. So, forces horizontal 0, that's 168 minus 108.15, yung na-compute natin na tension, minus RAH, yan, is equal to 0. Therefore, RAH is equal to 59.85 pounds. And this is our answer. So, ibig sabihin, tama yung assumption natin na ito ay pakanan at ito ay pataas. Okay? So, these are the solution for this topic wherein we've discussed about the non-centroidal rotation of this rotation, or what we call dynamic equilibrium. Okay? So, that's the end of our discussion in terms of rotation.